It's my great honor to welcome our guest of honor, Mr. Leo Peter Charles, sir. Welcome you, sir. And
Thank you.
I welcome all the participants present in the session. Now, it's my pleasure to introduce our guest of honor. He is an avid aero modeler and a drone platform evangelist. He has a bachelor's degree in aeronautical engineering from MVJ College of Engineering. He is also a serial entrepreneur who has the experience of having startups in IT, hobby retail, and UAV training industry. He has had all opportunities of training 100 plus drone pilots for the drone industry who are now employed in 15 plus companies. He has trained more than 5,000 plus students in aero modeling in his career spanning of 6 years now. Mr. Leo Peter is the aerospace consultant for various academic institutions like BIT Bhopal, MVJ College of Engineering, Agni College of Technology, and he is also an aerospace consultant for many companies. Mr. Leo Peter Charles completed his journey as the CEO of Garuda Aerospace Private Limited recently. This was JMA's first project as a part of JMA's ecosystem support endeavor, also called as JMAE
JMA.
program. The company became India's largest drone service company and became one of the three drones company invited by NDRF to assist them at Uttarakhand glacier disaster site. Leo Peter Charles formed Jain Aerospace Private Limited in 2019. JMA is a startup ecosystem
System.
whose primary purpose is to assist the aerospace industry in scaling up. JMA is an evangelist for the aerospace industry, especially the drone ecosystem, and strives to link the dot to the complete picture. JMA have worked tirelessly to raise awareness, provide infrastructure support, test site access, provide a skilled aerospace workforce, provide business solutions, train students for industry and foster industry, academia collaboration. JMA so far has conducted more than 200 workshops, professional talks, webinars, and seminars in numerous top institutions, colleges, and organizations to help given an insight into the industrial working of drone and aerospace sector. JMA has currently trained 61 drone pilots so far, and all of them have been successfully placed in top drone companies pan India. We are blessed with your presence, sir. It's time to know the insight knowledge of applications of drones in windmill inspection and technology. So, let me hand over the session to a great founder, Managing Director, JMA, Mr. Leo Peter Charles, sir, to carry on the session. Thank you, sir.
Thank you so much for that introduction. And I think one more thing you missed out is I am also the student of Professor Nishant when he was teaching at MVJ College, and then he's always been guiding all throughout this year from when I was in college way back in 2000, between 2009 and 2013. Uh, Thank you so much, sir, for the opportunity. It's really nice to come back to East West College of Engineering and then be able to present uh, a few thoughts and experiences that I've had with the drone industry. I've been doing a lot of work with East West College of Engineering, and it feels like coming back to home when speaking. So I was really glad that I could do this. So today's discussion, the aim of the webinar is to create awareness about what drones can really do and what are the potential it holds and what opportunity it holds for the upcoming engineers and especially aeronautical engineers and how we can go forward with it. I'm always excited about drones, and that is why I love talking about them. They've really changed from what I knew way back in 2014-15 to now. Drastic changes in all spheres. Today we have drones putting concepts or even prototypes out there where they're putting satellites into space. And then with the landmark achievement of flying drone on another planet, we've really pushed the boundary. So everybody used to tell the sky is the limit. I say the sky is just the beginning. And with that, we will go ahead. Today, I will be talking about how drones are being used in windmill inspection to increase efficiency, to increase life of the windmill, and then also uh, how this has become more cost effective, efficient, and is not putting people in harm's way. Uh, we will take a look at it. I will take questions at the end of the session, and hopefully you have a lot of questions. That way, it makes it more interesting to present. Next slide, please.
Thank you, sir, for your such a valuable advices and information's depth into this knowledge.
Thank you. So let's start. Uh, this is what I'm looking to cover today. Very briefly, we will talk about drones and then we'll get straight into the topic because that part of the introduction is always required. Many of you are new to these webinar series, and then even the drone industry. I think that is very important to cover. And then we'll see how it works and how any one of you who would like to be an entrepreneur in this segment can start off with these services. Next slide. So what are drones, right? We've been hearing about them, seeing them at weddings, at events. Some of you have even built it in your college workshop. What truly is a drone? So conventionally speaking, a drone is anything that is autonomous, a vehicle that is autonomous. It can be something that mimics an animal like a bot, but then working remotely. It can be a ground vehicle like a rover. It can be unmanned boats or unmanned submarines. And then we also have unmanned aerial vehicles, right? So all of these that are unmanned and remotely piloted or controlled through a command and control link is a drone. I work exclusively in the UAV segment, that's the unmanned aerial vehicle segment. Very interesting platform, and a lot of applications keep coming in day in and day out. We have applications in photography, cinematography, surveillance, survey and mapping, agriculture, industrial inspections, uh, both both in GPS available location and GPS denied locations. We have more applications where we are doing tracking of target for target acquisition, or what we call the I-star mission payloads. And it's just endless. We have drones now doing painting. We have drone. Yesterday something interesting that I saw. There's something called as drone football, right? Or drone soccer, where a team pilots multiple drones inside on a football field, and then there's one. So you have like one target striker drone on both the sides, and then you're trying to get it into the goalpost of the other team. So that was phenomenal. Something that I read about yesterday. And really, even in sports, be it drone racing or freestyle, or even such games that have come right now, like even laser tag on drones. So sport itself is being, or high speed sport itself is being modified, and literally drones are being deployed everywhere. So I have this common saying that drone application is limited by human imagination. Whatever people can imagine right now is possible with drones, or it will be possible in the future with drones. Somebody imagined that they could put a drone on Mars, and then we are seeing that reality today. Who knows? Tomorrow we might be using drones to mine asteroids. We might be using drones even to bring maybe a cup of tea from your kitchen to your living room. This is all possible. It's just that somebody has to imagine it, and somebody has to find a very good business case out of it. So this is what drones have really become, an extended arm for humans to achieve uh, projects or to achieve feats that were earlier dangerous or time consuming or very expensive. Next slide, please. So what are the type of drones? There are multiple types. The usual one that we see is the multi-rotor variant, but then we have other segments as well. So let's take a look at it and then briefly see what are their advantages, disadvantages, and then small use cases. Now, fixed wing systems are the early drones that came in. They look like a bird, look like an aircraft, and they fly like one. You have longer endurance with them, lower power consumption, all of that. And another beautiful part is they have a glide ratio. So in case an engine fails or the motor fails, you could still safely land the aircraft if you have enough velocity. Now this second part would be the rotary wing or the single rotor helicopter. These were, after the fixed wing, these were one of the early drones that came out, or UAVs that came out. And initial application was in cinematography plus agriculture. Way back in 1998, Yamaha built these helicopter drones for crop dusting, and they're being used right now and then being explored. So we have the Sheeble camcopter S1000, and then we have a lot more. We have the Anavia and all of them using the same concept for heavy payload lifting and vertical takeoff and landing. That's the most advantage that the single rotor provides. And then greater agility and maneuverability that is more than what the multi-rotor can do. The multi-rotor is a very stable platform. Vertical takeoff and landing, again, it can hover at a place and then has the ability to overcome large gusts, that way giving you a stable feed from the camera or any other payload where visual data is being transmitted. The problem with multi-rotor, one is you do not get enough range. Endurance is limited to under 2 hours depending upon what power configuration you have. And in case one rotor stops, the drone will fall like a rock. That's the biggest problem that it has. Multi-rotors, apart from the tricopter, the rotor configuration is always in even numbers. That's another thing that you will have to bear in mind. So these are the basic three type of UAVs. And then we have the hybrid VTOL, combining both the fixed wing and the multi-rotor. The multi-rotor configuration in the hybrid VTOL provides vertical takeoff and landing, whereas the fixed wing configuration in the hybrid VTOL provides you fixed wing form of flight for longer range and endurance. This way, you don't need a longer runway, you don't need a catapult, or you don't need to hand launch the drone. They've combined the multiple advantages of the fixed wing and multi-rotor into one. This is now the most commonly used drone for surveillance, because you could take you only need a patch as big as the drone for it to take off. Now the ornithopter, a very interesting use case. The earliest design may be of Da Vinci's, but today it has become a reality. The bird that you see in the picture is a reality, and you would have also seen the same in the movie Uri. So this bird, what they show here, is being used at large crops, like in the Western world or highly industrialized nations. Agriculture is under corporation, so they hold large amounts of land in thousands of hectares. Now, if you have to scare away birds, a scarecrow does not really do the job. So they use this bird, which is designed to look like a predator. The design here is of a peregrine falcon. And then this flies around scaring away all of the other birds. And then they generally don't come into this territory because they know there's a predator. So, and they've also used this one at Heathrow Airport to scare away birds at the airport so that you avoid bird strike. Bird strike causes a lot of damage, engine failure, radar damage, windshield damage. All of these problems exist. So one, the primary thing, it's a concern of safety. Second is the cost to repair those damages. and if your turbine blades get damaged or your combustor in the gas turbine engine gets damaged, it's all expensive to replace. And even if the radar dome gets damaged, it's very expensive to replace. So they use these birds to scare away other birds in the airport. Then we have the aerostat. The aerostat is basically a balloon working on the concept of buoyancy. You have helium filled in it. It can stay in the air for really long time, and it is generally used to monitor border areas, or also used in cinematography for matches that generally go on for a really long time, right? So that are the advantages. Each one has its own advantage, disadvantage. You will always need to choose what type of UAV that you work with based on your application or end use case. Next slide. So introduction to windmill inspection. So windmills, one of the major sources of renewable energy, and one of the major sources for carbon credit as well, is now being used along with solar power and tidal power across the planet for generating electricity to meet the needs of the country. Now windmills are generally 80 meters in height. That's like 250 feet, and the only way you can get to the top is either you climb the ladder through the mast, or you have a helicopter drop you on top. So, but the challenge is in terms of helicopters dropping you on top of the hub, is these locations are highly windy. The wind that, and there is always turbulence created behind the windmill, and that would mean it make it difficult for the heli to land or drop somebody, and it's always dangerous. So the other thing is, climbing up is you cannot take a lot of equipment up. It becomes very tedious to take the equipment up, and that way that's a problem. But these inspections need to happen, because over time, if inspections are not done, windmills will fail, and catastrophic failure is very dangerous, because anything flying off from the windmill can affect nearby windmills, and that is a huge challenge. And then fixing that entire mess is a problem. And stopping a windmill again is costly to the company, because that much amount of electricity won't be generated, translating into them not making enough money to sustain. Now, drones became very handy in this segment to monitor windmills. Multiple use cases: thermal inspection, ultrasonic thickness testing, painting of windmill tips. Here you could see the tips are orange, right? Even this was a recent rule that came in. So when you travel towards Chitradurga or Ballari, you will see that some windmills have orange tips, some windmills don't. But now it's been made mandatory that windmill tips are painted orange for better identification and other safety purposes. So that for you to now paint it is going to be a really big challenge. And then few companies are working on drones that can be used for painting these wing tips as well. Next slide. So we have different inspection methods. I've worked with Sizzlon during my stint as CEO of Garuda, and then we've seen some really bad use cases. You can see the pictures. These are all real windmill damage. So what they generally do is they have a very high resolution camera that's mounted on the ground that takes pictures. The problem with it is you cannot do upfront, and then you cannot do a very close inspection. Second is you will have to manually move the cameras to different locations for picturization, and you cannot have the sun in the at certain angles, because then you will never get the picture right. So that is another problem that they face. So that is one. Second is you will have to manually move from one windmill to another. The challenge with that is windmills are separated at a greater distance, and then they are at different hits. So mostly they are on hills, So you'll have to go down and come up again, and then that's time consuming, reducing the number of windmills you can inspect per day. So that is one method they did. Second was you climb up to the windmill, somebody lowers you down or tethers you down through a rope, and then you take pictures. The problem with it is, again, as I said, since these areas have high winds, you're always susceptible to swing, and during that, equipment can get damaged. The person who is doing the assessment can also be hurt. That also is a challenge, and with that much of wind, getting a stable photo will also become a problem. Now, what by visual inspection, by binoculars or any other method, the problem comes is you cannot actually tabulate data, right? That becomes a problem. And certain things like crack detection cannot be done with naked eyes. We cannot see in infrared region. So using other equipment became very, very necessary. And then drones became the most preferred method of inspection. Next slide, please. So these are few of the methods that are employed to understand. Subsurface inspection is very important because most of these blades are made from fiberglass to keep their weight low. The mast anyways is metal, but the blades are fiberglass. And you will need to understand crack propagation because in composite material, crack propagation works very differently in terms of, and when compared to a fully single metal or an alloy, right? Now you will need to understand the thermal images. You will need to understand the shear. You will need X-rays of it. You will need to understand the stress patterns that are being developed. And the best part also is if you are at a far distance and you have a very high resolution radiometric thermal camera, you can also see how the windmill is functioning, and you can also study various indicators like the thermal image or the stress image when the windmill is in action. This can not generally be done when during using other methods like either you tethering down or climbing the windmill. You will have to stop it, but here you can do it, but you need to maintain certain distance so that the drone doesn't get sucked in. And another advantage is all this data can be accumulated and you can always build an analytics out of it. Building analytics helps in multifold. One is it helps for better inspection next time. You can always build the flight path of the drone to an optimal level based on the input from the previous inspection. Second is the manufacturing companies can use this analytics to make better equipment. And third is maintenance schedules can be better planned because of these analytics. So all of these advantages are available. Next slide. So these are few of the images taken using drones, and then you can see the details in the image, paint being worn out, the flesh of the blade being exposed, how much of damage has incurred, and how you can also consider or take into account how you could repair these damages, right? That's another beautiful part about doing this. And then this happens in all of this data acquisition happens in a very short span of time. Next slide. Excuse me. So there are multiple ways we can do data acquisition with a drone. Before we go there, let's talk about the payload. You can generally have single payloads or a coupled payload. Single payload would mean a EO camera or electro-optic camera for high resolution visual images. You can have a thermal camera for thermal images. You can have other sensors to collect various different data. You can have an ultrasonic emitter to collect the thickness of the mast. You can also have X-ray equipment, contact based again, to understand cracks. So these different payloads will have to go on a drone, and then you'll have to choose a drone that could pick up these payloads. And you can also do a 3D reconstruction of the entire windmill using the EO payload, and that will also help better analyze how these windmills sustain the impact of weather over a period of time. Now, firstly, we do it manual method. So how this works is you go to a windmill site, you take off, and you take pictures at certain intervals of the blades, of the center hub, of the generator in the back. You take the pictures of the blades in the front, at the back, and especially on the tips. Then you take pictures of the entire mast. Uh, you have certain cameras that can take both electro-optic and thermal picture at the same time. They are called integrated payloads. So you can use that and then don't have to fly twice. These pictures are later collected, stitched on a software, and then a 3D representation is created. And places where you see extensive damage, you can always mark it. So blade 1, blade 2, blade 3, you can say at this distance this problem was there, because you would have taken the entire length of the blade, and with reference of the original design of the windmill, you can say at this distance from the blade you will find this damage. That's very much possible. And the in this, they fly in a designated pattern depending upon wind direction, depending upon how fast it needs to be done, and then better experience. Here, the experience of the pilot matters a lot as to how close they can fly to the blade and not crash the drone into it. So that all depends on the experience of the pilot. All pre-checks have to be done, and the number of photos clicked again is at the discretion of the pilot, even though there will be a standard operating procedure, but that evolves over a period of time. Manual data collection is well suited for certain aspects, not to cover the entire thing, maybe large scale damage and all of that. But the way to go ahead is for autonomous systems. Next slide, please. So this is the automated flight. This is the most preferred plan, where you have an AI-backed software and a computer that helps you plan the flight and then also tells the drone when to take pictures. Now, what's the beauty of it is the entire operation is not pilot dependent. Second is the drone chooses the best optimal route to gather the most amount of data that will make a lot of sense for the manufacturer to run the maintenance. Third is every time this happens, the program evolves, and that way it becomes faster to get things done. And basically AI doesn't have the hesitation that it will crash the drone into the windmill. Right now, when you fly from the bottom and then the hub and the blade above it is even higher, 250 feet and high, you will surely have parallax error, and depth of vision to understand how near it is to the blade and all of that becomes a challenge. And then if you have the sun hitting your face, that becomes another challenge altogether. But then this doesn't happen uh, with the automated flight. The collision avoidance sensors on the drone will always make sure it's maintaining a distance. The algorithm that is running on the drone will make sure that if this is the wind direction and this is the wind condition and this is what the gust speeds are going to be, what is going to be the safe distance to be maintained from the blade, the hub, the mast, all of that is there, and then it's continuously working. Manually flying, you cannot do that. It becomes very, very difficult. And another advantage with AI is if you have a strong enough computer that can process on the drone itself, then you can get real-time data, and then you can just submit the report then and there, or send the report once you finish the inspection itself. You would not need to take it to another center for post-processing, right? So that way, automated works better. And the third beautiful part about it is you don't have to land the drone after you finish one windmill. You could choose 5 windmills if you have enough battery time, that is. And let's say each inspection will last about roughly 10 minutes, and you have 5 windmills, and then you have a battery life of an hour. You can just map the windmill, The AI system on the drone will recognize windmills and move from one windmill to another based on the waypoints. And then once it recognizes a windmill, it will start its operation. So recognizing a windmill is very easy. One, either through computer vision, or you could generally draw a skeletal structure and then say this is how the windmill will look like, a 1D diagram. And from there, it can always pick up and extrapolate to what a windmill looks like. So that also becomes an advantage. So you can finish 5 windmills as fast as possible. Manual method, you could only do like 3 a day. Autonomous, you can do up to 10, depending on weather condition, depending upon your sun position and all of that. So that autonomous and automated flight makes it very easy. Next slide, please. So processing and analysis, first you will have to stitch the data. One is visual inspection. You will go and look at photographs and say, okay, this is where the damage is, this is what needs to be done. That's the report you submit to the OEM, and then the OEM takes a call, because there will be annual maintenance contracts. So generally, governments buy windmills from the original equipment manufacturer, or private parties buy, and they have annual maintenance contracts that cover the scheduled maintenance of the windmill as well. So they take this data and then say, okay, we do this to make the windmill more efficient. Second is 3D reconstruction. Third is trying to understand stresses. Fourth is you understand the thermal emissivity of the windmill as well. If your generator is getting too hot, that is also another challenge, right? So as you see here, the 4 important steps is: one is organizing and sorting data, data processing, data engineer review. That is basically an engineer from your side reviewing the entire data, the quality of it, and all of that. And then you send it to the expert at the OEM, who reviews it and then takes a decision as to what needs to be done next. So this is what it is. And typically, the number of images that form a turbine's inspection database would be from 300 to 400. Depends upon how old the turbine is, what is the detail we are looking at, and how critical it is for doing this. Now, you have drones that fly inside the blade and take pictures as well, which was not possible before, because a human can only go from the hub to 30% of the blade, whereas the drone can travel up to 70% of the blade. That is a great advantage, which helps to understand internal cracks. Second would be the ultrasonic thickness testing. It's a small probe. You fit it, or you make it to come in contact with the surface. It emits a ultrasonic wave. The difference between the wave being emitted and received, you will find the thickness. This even eliminates or takes into account rust, the amount of protective coating that is already there. So you will get true metal length to the accuracy of 0.1 mm. So that is manually done, but now it's being done through drones. When I was at Garuda, we built the first contact-based drone inspection methodology and the drone for doing ultrasonic thickness testing. And till date, Garuda is the only company in the country that can do ultrasonic thickness testing of metal structures. So that is also possible. You take all of these data; they're all multiple reports, but then when combined together, and when you have AI-backed processing available and AI-backed analytics available, it makes it more easier to say, okay, this turbine needs these problems sorted for us to increase efficiency. Next slide, please. So whatever I was saying, this is a brief explanation. The first part is where you capture data. The second part is where you organize the data depending upon the type, be it thermal, be it electro-optic, be it thickness testing, be it stress testing. All of that you could organize it differently and then provide the client. Then you have an engineer to review it, the reports, and then you provide it to the client, who would have an expert to understand how to interpret that data. Next slide, please. These are few of the companies. There are many more. These are pretty much who work on that. ABJ Renewables, they work all over the planet. The CEO of the company is a very good friend of mine. So they have offices in multiple locations, Middle East, North America. They either work with partners or they have their own setup, and then they expertise in providing this data sets to OEMs for better maintenance schedules and manufacturing. These are few of the companies. You can always take a look at that. Next slide. So what are the advantages? One is higher resolution images. You get images anywhere between 20 and 40 megapixels. That is first advantage. You have high resolution. So whenever you zoom, you don't have images pixelating at the beginning itself. Second is you can use thermal cameras that can help detect undue heat stress because of stress distribution. Second is centimeter level cracks that could really become fatal, or any other deposition or paint where you could see a different heat pattern that could that may not be visible on the surface, but then there is definitely underlying paint layer defragmentation that could be detected. Third is very cheap, right? If I have to get a crane or something like that, is going to be very expensive. If I have to hire a helicopter, it's damn expensive. And if somebody has to climb and do it, it's hazardous and all of that. In drones, right now is about 8 to 10,000 rupees per wind turbine with a report. You can easily do in manually. I'm telling you can easily do up to 3 to 4 a day. That's very cheap when compared to what they were doing earlier, and that's faster, more effective. If you have multiple teams, you could finish multiple inspections in the same day. And you have data sets. This is the so data is gold, right? You have this data set, and you can derive analytics out of it. You can derive useful insights out of it, and you can always keep evolving the analytics that you derive out of the data, and you can use the same data to make the inspection better. That is another added advantage. Man-hour reduction, definitely yes. Also, safety of the person. You don't have people risking their lives, even though they're safety gear. They're not risking their lives and doing these inspections. And you can always do real-time image feed and video feed. Now, what's the advantage of this is you can see at when you're controlling the drone, and then you can also stream it back to a command center or to the headquarters of the OEM, where they could give you inputs real time, and that would make the inspection better. This was not possible earlier with manual methods. This is possible now with drones. Next slide, please. So let's switch.
Using Force Technologies' advanced drones, it is easy to conduct blade inspections. The drones are continuously developed with image resolution and focus, providing unparalleled image quality. Remotely controlled without accessing the turbines ensures a minimum of downtime and production loss. After completing the on-site works, the data is evaluated by our expert, reported and documented. Using either visual imaging, thermal infrared inspection, or a combination of the two, provide our customers with full documentation of the blade surface as well as some structural information. Force Technology drone inspection provides an efficient mapping of visual damages to the blade, making it easy to plan repair works and general maintenance. Extent of inspection is done in accordance with customers' requirements, and reporting is delivered immediately after the evaluation.
So here you see this is a small video from Force Technology. Now, another usefulness of this entire thing is you don't have to wait for reports like a week. You take the images, you can always send it via internet to your processing center, and they could prepare it in a day's time, and then in 2 days' time you will have the report, which was not the case earlier. Second is, let's say you do manual inspection and then you climb up to the hub. By chance, if you leave any tool there And when the turbine starts, that is always catastrophic, right? So that is now being 100% avoided during the inspection fully. So this is another advantage that the drones have. Next slide, please. Yeah, let's take a look at the video. So here you can see visual and thermal at the same time. It's a split screen. That's how close they can go with the drone or zoom. Certain of these cameras come with 3x optical and then even 100x optical distance. Real-time feeds at a clear. That way it even makes it easier to give, or if there's a maintenance engineer on the ground with you, it makes it easier to tell them what needs to be done. Certain places, ice deposition also plays a very crucial role. That will also hamper the efficiency of this. So you have drones that clean or de-ice surfaces. What they do is they carry large de-icing agents that is sprayed on these blades that clean them. So this is another way to see. Next slide, please. Yeah,
Inspections in
offshore
order
wind
to
turbines.
identify potential damages and develop early stage solutions. In 2014, the visual working team of drone pilots and aerial imaging experts have achieved a result that will revolutionize the way that we look at offshore wind turbine inspection.
Bridge, we're taking off. Take off, yeah, we will stay in this position.
The visual working team has inspected the entire Bellwind farm by the exclusive use of aerial imaging.
Here you see they inspected windmill as stop, and then the other ones are still running. That's another advantage where you don't have to show the images in details.
This wind farm is located at 46 kilometers from the coast and is made up of a total of 165 blades. Visual working proved to be capable of delivering images of superior quality, with inspection time cut by 70% versus the standard approach of using rope technicians. A blade is inspected from all of its
So yeah, there's a very long video. You can always take a look at it on YouTube. So here another challenge that they've resolved is trying to dock the boat near the windmill, right? That is also a challenge where that is all time consuming. Here the drone just takes off from the boat and then does the inspection and comes back. And you really don't have to dock the boat near the windmill, then climb up, and all that time consumption or the time wastage that is there, that is being avoided. Next slide, please. You will see most of these inspections are being done by multi-local systems. Not the great. And here you see the helicopter configuration for inspection. Predetermined flight modes or flight paths that they enter, and then based on that capture the next flight you pack the helicopter and then. So here you can see how the post-processing and how they can even simulate things based on the problems that they face or they have spotted using it. That's a damage. Right? So you can photograph that, and then that will definitely cause problem in the efficiency of the windmill, and it is also easier to measure the dimensions. Draw a polygon and then see what's the area. Let's go to the next slide, please. So this is the internal inspection that I was talking to you about. From Helios 2 is a company in Switzerland called Flyability that has made this video. This is the drone flying inside the turbine. So that was their recent use case, and it also makes sure that there is no damage to the turbine because of either any equipment being left inside or due to other human error. So that, and you can go further into the turbine blade for inspection. Next slide, please. So that is about how drones are being utilized in the windmill ecospace or the wind energy segment. Let me just introduce the organization as well. I generally do it at the last. So I started this company in 2019 to help other drone companies scale up, because there were companies that were manufacturing drone products, there were companies that were providing drone services, but there's nobody in between connecting the dots to help them scale, because we missed the aerospace wave way back in the 70s and 80s because it was highly capital intensive, right? But for me, my wish is that we don't miss the drone wave, and that is why we are building. JN Aerospace works as an ecosystem supporter, helping companies scale up and then expanding all over the world. So that's the whole idea with which I founded the company. And today we've been supporting a lot of manufacturers and service providers with a lot of services that we provide as part of the ecosystem support. Next slide. So these are a few of the services that we offer to the companies. We provide advanced drone pilot training program because that's one of the segments that these companies are facing a lot of challenges in. Apart from that, we also help them with other skilled manpower, brand consultation, market analysis, test site support, government liaising, and with investments. And then we also keep alive the tradition of aero modeling, because that's the crux or the core of the drone industry, and hence we have an RC flying field in Hoskote where a lot of RC enthusiasts come and fly there. Next slide. So this is the advanced drone pilot training course. Many of your seniors have taken this and are now successfully working in multiple companies. This is one of the extensive drone pilot training program that is there in this country, where it is for about 20 days. And we give you 15 hours of real-time flying, 15 hours of simulator. We also have soft skill training to prepare you for interview. And then we also take you through advanced programs in that itself, where we help you learn how to use drones for agriculture, cinematography, mapping, and survey. And we also cover DGCA syllabus. So it's a full-fledged package, and then it's built on the recommendation from the industry itself. And that is why we have a very high placement rate in the program. Next slide. So this is something that we are starting new, the Flight 100 program. This is my personal favorite. The aim of the program is to create 100 entrepreneurs for the drone industry, be it manufacturing, being an OEM for a drone, or being a service provider, or being auxiliary or ancillary manufacturing units to provide parts, right? So 100 people from around the globe will be selected based on an interview, and myself and my team from across the globe of leading entrepreneurs from various industries will talk, mentor, and then we are also looking at creating minimum of 50 to 80 startups by the end of the program. So that's another thing. That's another program that I am looking forward to. Tentative start is at the end of mid or end of July. We will keep you posted. I think Praveen just put in the feedback link. You can fill it up, and then if you're willing to be part of this program, you can always say an S, and we'll take you up for the interview. So that's it for my presentation. Next slide, please. You can always follow us on our social media sites for more updates. We are looking to, I want to do these webinar series for the rest of the year. So we will mostly be doing it on the weekends on different topics, different improvements in the drone industry, different products that are available. And we will also have CEOs of other companies come and talk, product development managers, CTOs of other companies from across the globe come and talk to us. You can always follow us on LinkedIn and Instagram to stay updated. We also write a lot about different types of drones, so you can always stay updated, because a lot of people ask me this question: how do we stay updated with the developments in the drone industry? You can always follow us, because we keep sharing a lot of information about drones from across the world, since we work with a lot of clients from various parts. of the country and the world. So that's a nice thing for us to be doing, and then it also helps build this ecosystem, because we need more people, more thinkers, more doers come into this segment to really scale this industry. You can always write to us if you have queries, or you can ping us on any of our social media platform, and then we will always reply in due time. Thank you so much. I would like to thank the management of East West College of Engineering, HOD sir, uh, Assistant Professor Bhushan, for setting this all up, and then working with my team to have this done. Thank you so much for the opportunity. Please fill back the feedback form. We would like to know how to improve this program, this webinar series, and then make it more interesting, informative, and then help create an action plan for you guys. Thank you so much. Open to questions.
Thank you, sir, for providing an insightful knowledge of drones and their types in the applications with different fields, windmill inspections and method inspections, and many more. Thank you, sir. Now I request our beloved HOD, Head of Department of Aeronautical Engineering, Professor Nishant P. Sir, to give the vote of thanks.
Okay. Good morning, everyone. Thank you, Anjali. Leo.
Yes, sir. How are you, sir?
Yeah, I'm doing good, Leo. How about you?
Thank you. I'm doing good, sir. Thank you.
So I can see the same enthu as that you're physically present and doing the presentation. It was very good, enlightening session.
Thank you, sir.
So the students would have seen the thing about the different application towards the drone in different domains. So with the practical knowledge, what and all Mr. Leo Peter has come across, has put forward in front of you and explained the things in a easy and understandable way. So in this regard, whenever we ask for any kind of a thing, the first person comes into my mind as well as Leo Peter's mind is East West and Leo Peter. So whatever thing we decide, we'll have a discussion with Leo Peter, and vice versa will happen, and he will give a suitable suggestion for us. So let's go in this direction. Let's work it out in this way. So always you will be a part of our department in each and every activities. What and all has been initiated till today. Take up about the gliders. He was there with the gliders. Take about the UAV. He was the main person behind that UAV. The feel of that UAV felt by an aeronautical engineer is so wonderful feeling. He was the first person to give that feel to East West Group. So I don't have any words to say much more about Leo Peter. He is doing the things in a very, very, very professional way. The presentation also was very professional. And Leo, please be in touch with our students, because
Yes, sir.
the students requires a mentor like you, because I know how much you have struggled to be in this position. The same struggle has to be taught to the followers of you, so that they also succeed in the same path, right? So in
Yes,
this
sir.
way, I thank Leo Peter, and I appreciate his presentation, and I'll appreciate his time taken to enrich the knowledge to the aeronautical fraternities. So once again, I want to thank Leo Peter and his company. In this occasion, I would like to appreciate and thank Dr. Santosh Kumar, the principal. Whenever we go with any kind of an this thing, he says one word, "Go ahead, sir." So I would like to thank my principal as well as the management, right? So Leo, be safe.
Thank you, sir. Same to you,
I'm
sir.
happy.
Be safe.
Yeah, sure, sure. So I am happy to see you with the same what to say brightness while doing your presentation. Awesome. Keep it up.
Thank you,
Keep
sir.
on enriching the knowledge to others. Keep on building the society in a positive way. Thank you, one and all. Thank you, guys.
Thank you so much, sir, for your kind words. Hopefully, my presentation has improved from when I did my seminar way back in college till now.
Long, hell lot of difference.
Thank you. Thank you so much.
Yes, Leo. Thank you. Thank you.
So if anyone has any questions, you can ask. I think we can take 1 or 2 questions, and later you could always reach out to us, and we could answer them.
Hello, sir.
Yeah.
Good morning.
Good morning.
I'm Rashmi Raj from Vanastali Vidyapet.
Yes,
My
please.
question is basically in what principles UAV work?
You're asking about the physics part of it or the electronics part of it?
Electronics part of it.
So basically, you have a flight controller that helps differentiate or increase or reduce or keep constant the RPM of the motors. Depends on what UAV you're talking about as well. Now, if you're talking about fixed wing UAV, it works like a normal plane. You need to achieve minimum takeoff velocity for it to take off, and then you will have to have a cruise speed for it to continuously fly. The flight controller is at the heart, is the brain of the thing. The power system is anyways the heart of it. So the flight controller is in its basic form is an Arduino based, to put it in very simple terms, but then now it is more complicated, and it controls all aspects of it, be it the transmission of data from the UAV to the ground control, or from the receiving the data from the ground control to the UAV, and then controlling different control surfaces on a fixed wing and the power system, or in a multi-rotor controlling the RPM of all the motors. That way differential thrust comes into picture, and then you fly it. So that's at the heart of the thing. And then you have different components of it as well. You have, if it is an electric drone, then you have an electronic speed controller or motor driver, as you call it. And then you have a BLDC motor, a brushless DC motor. Depending upon what amount of power you require, you have a motor and propeller combination. And you have servos on a fixed wing drone. You don't have that on multi-rotors. You have power distribution board, power management unit. You have telemetry system for data transfer. All of this comes together and forms a drone. The components, the electronic components that go onto a drone depend upon application and the size of the drone.
Okay, sir. Thank you. And the physics point of view, which principle used?
So for fixed wing, you have Newton's third law, and you have the Pascal's law of partial pressure. That also works. Newton's third law also works. It's always going to be, or you have Bernoulli's principle that is also into picture. It's still a debatable topic. Nobody's come to a conclusion on that.
Yes, sir, because I read a note. So basically, I related the UAV to the aeroplane. So I am searching for the which principle UAV work. I am not getting any answer. But what
So
principle?
the answer is that
aeroplane
you
work?
either take Newton's third law, or you go through Bernoulli's theorem,
Bernoulli principle. I get the answer for the
or you
aeroplane
can
one.
go through circulation theory and understand how it works. But there is no single definition till date. It is still all debatable. Multi-rotors work again on differential thrust for maneuvering, and then you still have moving lift generating surfaces. That's the propellers, right? So they provide thrust and then keep it up in the air. So you have differential thrust. That is definitely Newton's third law that pushes it up. But then the way the propellers generate thrust again is coming back to the same question of, is it Bernoulli's theorem, or is it circulation theory, or is it Newton's third law? All of them might be interconnected, but then it is very difficult to tell what is definitely happening. Circulation theory will mostly give you a very close answer to what's reality.
Thank you so much, sir. Thank you.
Any other question? Anyone else? Okay, so if there's no questions, we'll conclude for the day. You can always write to us at info@jnaerospace.co.in, and then I will be more than glad to answer your queries. Thank you so much, everyone, for your patient hearing. Please do fill out the feedback form, the links in the chat, so that you could get your certificates, and then we can get our valuable feedback to improve this program. Thank you so much, everyone.